Hey everyone, we're going to play with the Better Navigator today and do some navigating with a Lidar and a robot. So what I have here that we're going to be using, don't be intimidated by all the hardware on this guy. We're only going to be using the Lidar. I'll turn the camera on just so that we can see what the robot's doing, but we're not going to do any like vision tracking or something. So this is a Robotis Turtlebot. It's a good platform that I like to use for testing sensors and testing various different lidars and stuff with, specifically because it's so modular, right? You can just screw anything you want in. Now, what lidar we're using today is the RPI lidar. So if I were to, I'm not even sure which USB port here it's plugged into. Oh, that one. So you can see here, RP lidar, not RPI lidar, sorry. RP lidar. And don't worry about the Intel RealSense. We're not going to be using that today. So we're just going to use the RP lidar. We have an onboard computer running Windows. This is a Rock Pi. These are great little devices. Plugged into it is a USB. This is an HDMI faker, I guess you can call it. So it simulates a monitor, because without this plugged in, the graphics card will default to a resolution. And that resolution, I think, is something small, like 800 by 600 or something ridiculous. So with this plugged in, we can set the resolution to 1080, whatever the graphics card supports. So we also have Wi-Fi. It's powered by, the Rock Pi is powered by this brick. So there's a power brick. I think it's, I don't know how many amps it is. It's, well, it says it's 20 amps. Whether that is correct or not, who knows, right? Amazon. I don't know why we're not focusing on that, but you'll have to believe me. That's what it says. And as far as, that's just running the Rock Pi, right? It's plugged into USB-C, and it's running all the accessories. And then for the actual movement, for the robot to move, we just have a 11-volt LiPo 3-cell plugged in there, hooked up to a Robotis, I can't remember what microcontroller that board that is, but, and then it's connected to these Robotis Dynamixel servos. So what we're going to do is, first we're just going to try to make sure we get this thing working, like driving around. So I've already installed VNC on this computer, and as you can see, we're VNC'd into it. And from here, we should be able to load up ARC. Now, I already have a project that we can play with if we want to just see how it works. And then I'll create a new project from scratch to show you how to do it. So this project here is one that I've created. I guess we'll put it on the ground first before we start the LiDAR up. But let's just make sure this robot drives. We'll connect to it through our connection here. Intel RealSense, we can get rid of that. We're not going to be using the RealSense. And everything else that's here we will actually be needing. So let's just make sure we can drive. Yeah, we can. Perfect. So let's place this guy in the ground. And that'll be our home position, the starting position. So what I'm going to do is get back to our desktop here. We've connected to the robot. We know that it drives. Now let's start up the camera so we can see what the robot's seeing. So we'll put this here. Now let's start up the RPI LiDAR. So we can see it's starting to detect the room, which case I guess we can start driving the robot around. And we'll see what the room starts to look like. Nice. Okay. So we're starting to get a good idea of the room, and you can see that the room is getting mapped out. And we're driving up to a snowboard here. Okay, so our home position is where we started. And I have a fireplace here. I guess that's because last time I ran this, I was probably at my cabin and was playing with it. So let's select home and then say go to the waypoint. So it's going to navigate, and it created a path. As soon as I selected it, it created an automatic path on how to get there. That's using a path planning algorithm. So if something were to get in the way, it would automatically create a new path. And you can start to see the room really building out, because, you know, as it's a 360-degree LiDAR, anything that's in the way will prevent it from seeing stuff behind things, right? So that's why we're slowly starting to see things that it's learning as it drives. Okay, so we should be home. There she is. Booyah. Now, where we just were was someplace up in this area here where the stairs are. So if I were to right-click and say add a new waypoint, I can call it stairs. And if I select it from the list here on the left, here you'll see that it's created a path that it thinks, oh, this is how I know how to get to stairs. So if I were to put something in the way here, it would actually create a new path in order to get to stairs. So it'll dynamically create the path based upon what's in the way. And let's instruct it to go to where we just were, to the stairs. And there we go, we reached our stairs point. And if I were to select home again, you're going to see it's created a path right to home. What I'm going to do is I'm going to put a box right here, and that's going to prevent the robot from being able to drive that way. So we're going to see, once the box is there, we're going to see that the better navigator is going to figure out a new path on how to get to home. So let me go just do that right now. I'll turn the robot around so you'll be able to watch me place that box there. So now there's a box in the way, and it thinks that this is the way it's going to drive. So let's just say go. So we're telling it to go to the home position right now, and off it goes. So it says, I can't go that way, and the path changed, and now all of a sudden, poof, we're going a different route. It's decided that it knows how to get to where we're going. We've reached home once again. So let's start the project from scratch and show you how we just did everything we did so that you can do it too. So we're going to first connect to the robot controller. So that is on COM port number 3. We know that. I mean, we can test each one. We can connect to each of these COM ports and see which one is what. But we know it's on COM port 3 because the project we were just using. And now what I'm going to do is I'm going to add in a servo driver for the Dynamaxle servos, because that's what we're using. And there we have the Dynamaxle servo driver. So let's edit this. I believe that our Dynamaxle servos are connected to port 1. We're not sure yet. So why don't we just do a test. We can go to utilities here and we can do a scan. Okay, so that wasn't correct. Let's try port 0. Okay, let's try port 2. There we go. So port 2 it is. And we have an XL430 or XL320s found at ID number 1 and number 2. So what we'll do is we'll go to ID number 1, number 2, and we'll select those as the XL320s. I think that they're the XL430s actually. We'll select those. And the number of positions, that's fine as well. And we'll save that. Now, we want the robot to be able to move, so we need a movement panel. So what we'll do is we'll add under movement panels, because these are servos, they'll operate like continuous rotation servos. So we're going to run the continuous rotation servo movement panel. And what I'll do here is we'll add V1 and V2. We have no idea if these are going to be correct for movement yet, so let's find out. Rather than just pushing these buttons and moving, why don't we add in a joystick? It's just a little easier to work with. So if I go into Remote Control tab here, we have a movement joystick, and this is nice to use. Let's configure that and see if there's any settings need to be specified. No, max speed of 255 should be okay. So we'll push forward. I don't see a robot moving. So let's take a look at our Dynamax configuration here and see what we're missing. Oh, here's what we're missing. Under mode, it's under position. We want to turn this to wheeled. Oh, I hear it moving. Let's take a look. Now the thing is, it looks like it's completely backwards. When I go forward, it's going reverse. When I go reverse, it's going forward. Let's take a look at the servo movement panel. And I'm guessing that this one needs to be V2, and this one needs to be V1. So the left and right wheels need to be swapped. Now let's try it. Okay, something's a little bit goofy here. We can go forward, we can go reverse, but when we turn right, we're turning the wrong direction. So we can reverse these forward and reverse values. Now let's try it. Oh, that looks better. Left and right is working now. This is great. Our robot moves. Now let's add in our camera so that we can see what the robot's actually doing. There we go. Yeah. Perfect. So now let's add the Lidar in so that we can get that working. And that's going to be under the navigation tab. And there's a few different Lidars here. This is the one we want, which is the RPI Lidar. And we can select its COM port, which I believe is COM port 4. That's what we used before. There we go. Oh, we can see data. This is wonderful. So we can stop that because we don't need it running right now while we configure it. So let's go into the configuration setting here and let's take a look at what we have. So we can say the baud rate, how many degrees it's on and off. Well, I can tell you this is that it's entirely reversed. It's 180 degrees off because I mounted it onto the robot backwards. Okay? And of course you can figure that out pretty quickly when you start looking at the map that the robot is making. And then we have something here, set variables with location data. We're not going to be using the variables. We're not going to be doing any scripting, so I'm going to keep that. They don't need to be checked. And we're going to fake the NMS pose hint event. That's the navigation messaging system. What it does is it'll take the data from different sensors and different pose sensors, and it'll create a map and a path planning, all that jazz, all the good fun stuff. So what we're going to do is we're not going to be using any wheel encoders, and we're not going to be using anything like the Intel T265 tracking camera for getting a pose hint. We're not going to do that. We're going to do all the pose hints internally with the Better Navigator's Hector algorithm. So we're going to select that. That just means we don't have to use any other sensors like wheel encoders. Of course, you can put your cursor over top of the question mark and read a little bit more about it, or you can click on the question mark for the robot skill and read more about it. So the next thing we need to do is add the Better Navigator. It's a wonderful naming convention. We have the Navigator and the Better Navigator. And the Better Navigator is indeed better. So let's configure the Better Navigator. Let's take a look. All the different settings. So we can have scripts that are going to run when the navigation starts, when it ends. We can have the robot speak and say, you know, I'm going to the living room, or I'm done navigating to the living room. And we have variables that can be stored, but we're not going to set the real-time variables because we're not using those. And we can save a little bit of memory and processing by doing that. Now under navigation, so we have a bunch of different settings in here. We can disregard distances that are within anything less than a distance. It's probably important to do. Just looking at the robot, I think 30 is probably too long. I think we can probably do 15, just because the robot's only about 30, so 15 centimeters is fine. Disregarding distances that are higher than a certain distance. This is because the LiDAR might not actually return accurate values above a specific distance. So this is 5 meters. Now pause the navigation if the distance is less than a certain degree. So if it runs into an object, we want the robot to stop, but we're going to keep that off. We don't need that. And how much history to keep. So it's going to draw a line on the screen as it drives, and how many of those points is it going to keep behind itself. 50 is fine. And this is the number of pose frames to update path planning. So what that means is every time it receives a pose update, which is an idea of where it is in the room, how often is it going to update its path to its destination? Because it's not going to update every single time it gets a pose, because then your CPU is going to just be going bonkers doing so much calculations. Our font size is on the display, how big the font is going to be. Our path planning resolution, and again we can read about all these different settings here. How big the robot is, so its personal space. In this case, our robot isn't very big, so we can make it something smaller, maybe like 50, like half a meter. How many path planning iterations? So when it goes to do the path plan, this is a number of attempts it'll try at getting the path planned. And again, you can read all these different values and experiment with different settings. So this is going to configure your movement speed, so you can see how fast we're going to be moving forward. And then we can enable dynamic turning, which is how quickly we're going to be driving forward and turning at the same time. So the degrees of forgiveness while turning is, don't bother turning if the object is, say, less than 10 degrees in front of me. So if it's less than 10 degrees in front of me, I'm not going to bother turning towards it. But if it's, say, 50 degrees out, it will turn. So this is really just like your accuracy of how close it should turn. And then finally, we have these values down here for dynamic turning, like I said, which is when the robot's driving forward, it will turn slightly to the left or slightly to the right. But it's only going to do that if the degree difference is less than a specific value. So if it's less than, we'll just say 30 degrees, then dynamically turn towards the object. Where this type of turning up here, this is actually a turn on the spot. Okay, this is a complete dead stop turn on the spot, where this one is driving forward and turning. You're not going to want to drive forward and turning if the object is a further, or the destination is a further number of degrees away. So video stream allows us to publish the data, the image from the LiDAR and navigation into a camera stream. So we can use it through Exosphere or through interfaces. And then we have some advanced tabs for enabling different values and stuff. Now, the pose hint is going to be important because we're going to want to use the pose hint from the Hector. Now remember, we specified the value inside of the RPI LiDAR that said fake the pose hint. Well, by faking the pose hint, we need to specify where the pose hint is going to be coming from internally within the SLAM algorithm. External means it'll be getting it from an external sensor like a T265 Intel RealSense. Average is an average between the two. Differentials is obviously a differential between the two. So what we're going to do is we're going to say use the Hector. Let's start the RPI LiDAR. There we are. And we can see here our room is starting to map itself out. Now let's start driving the robot around. And we'll create a more detailed map by doing so. Okay, so we have our home position and we know where the robot is, and this is kind of neat. Look at that. The shelf has been detected, all the different compartments within the shelf. Isn't that neat? That's wild, actually. So let's navigate to our home. So we'll select it. Now it says, okay, I think I know how to get there. And let's say go to the waypoint. See how it navigated right through the toolbox and that pillar? Oh, this is fantastic to watch. Here it comes. Okay, we made it home. And what we'll do for fun is let's go to our second workspace here, and we're going to add an interface. Under Remote Control, Interface Builder, And now under this interface, we're going to add the camera. We're going to add a joystick pad so we can have the robot driven around. And then let's add a button. And we're going to edit this. We're going to call this button Go Home. And we're going to edit the button. And what we're just going to do is we're going to right click and we're going to query all of the robot skills to find out what they can do. And here's the Better Navigator. And we can select Go to a waypoint. And as you can see here, there's a waypoint already called Home. So we'll select that. And we'll click Save. We'll make this our default interface. And now if we go on to our full screen menu, there we have it. So we can push the Go Home button and the robot will start navigating home. But what I think would be even really neat is if we could do this from our phone. So why don't we do that? Why don't we go to our project and go to our Properties tab for the project, and we'll go to Remote UI and enable the Remote UI server. We have the port specified. Now we just need a password. I'll put my secret password in of 1234. That's the one we're going to use. So on my mobile device, I'm going to load up the Arc UI app, and it's going to automatically scan and find any of the robots that's on the network, which we just discovered one, Turtlebot. We'll select it, and then we'll go to our password and we'll type in 1234, and now we're going to say connect. There's our interface we just created. So we can drive the robot around as we please. So what we can do is we can say go home. I could do that, but why don't we go one more step further? I know I'm going to keep leading you on here. Let's see what else we can do. So we know that on our app, we had an option in the Better Navigator to send the video of this to a camera. So let's do that. Let's add another camera. And on this camera, what we're going to do is we're going to specify custom. And we'll start that camera. Now we're going to edit our user interface. And we're going to add another camera. In this one, we're going to drop down. We're going to select our camera number 2. Of course, there's nothing in there right now, right? Let's go back to our main workspace. And under the Better Navigator, we're going to edit the configuration. Under video, we're going to push the video stream to the camera number 2. Now let's take a look at our full screen interface. Look at that. So let's revisit the mobile app. And as you can see, we can see the robot's navigation. We can use our joypad to control the robot. And then we have our Go Home button. So we push the button. Now we sit back and watch the robot drive home. So that wraps it up for the Better Navigator tutorial video. Hope this was educational, and I'm excited to see what you're all going to make with it.